Welcome students to our series of matrices. So today we'll start our lecture 3, that is based on different operation of matrices. In lecture 1 we have discussed the definition of a matrix and order of a matrices. In lecture 2 we have discussed the different types of matrices, and today we will discuss the different operation of matrices. So let's start our today's video with addition of matrices. So we have taken two matrices. This is one and this is another one. So how and when we can add two matrices? So if we are given by two matrices and the order of that two matrices, if they are equal, then only we can add two matrices. So here the order of this matrix is 1 to 2 row, 1 to 2 column, that is 2 by 2. The order of this matrix is again 1, 2, that is 2 row, 1, 2, that is 2 column. So you can clearly see that the order of these two matrices are equal. So if we name it A and we name this matrix as B, then order of A is equal to the order of matrix B, right? So that is how and that is when only we can add two matrices. So let's find out the result of A plus B. So if we add these two, then what will happen? So basically when we add to matrix, we have to add all the element of the matrices with the respective element with the another matrix. So as for example, this is the position of 1 is A11, small a11, right? Small a11 is equal to 1, that is this one. So we have to add this one with the a11 element of B. So let's add this 1 plus 5. Next we have a12. So we will add the corresponding a12 element of B2 of B matrix. So 2 plus 6. Now see, this is the element of A21, right? So 3 will be added by 7. 3 will be added with 7. The last and the fourth element is 4. Corresponding element of 4 of matrix B is 8. So 4 will be added by 8. Now add this. 5 plus 1 is 6. 6 plus 2 is 8. 3 plus 7 is 10. And this one is 12. So this is the answer of addition of matrix. So our next operation is multiplication of a matrix by a scalar. So what happened when we multiply a matrix by a scalar? So let's take a matrix. Here we have taken a matrix capital A whose elements are 3, 4, minus 1 and 2. This is a matrix named capital A. Now if we take any scalar, as for example 1, 2, 3, 4, here I have taken a scalar which is generalized, that is small k. So if small k is a scalar and if we multiply small k by the matrix A, then what happened? So if we multiply small k by A, then it will look like that. But what is the result of this? When we multiply any scalar by matrix, then all the element of the matrix will be multiplied by that scalar, right? All the element of the matrix will be multiplied by the scalar. Here the scalar is what? Small k. So if we multiply small k with all the element of the scalar, then it will become k into this, k into that one, k into the third element and k into the fourth element. So the resultant is 3k, 4k, minus k and 2k. Now if you take 1 as a scalar, then what will happen? It will remain unchanged, because if we multiply anything with 1, then the result is that number or that matrix itself. So if we multiply or put k is equal to 1, then it will become 3, 4, minus 1 and 2. So if you take 2, k is equal to 2, then what will happen? So let's take k is equal to 2. Then the matrix become 2a, right? And the resultant become 3 into 2, that is 6, 4 into 2, that is 8, minus 1 into 2, that is minus 2, 2 into 2, that is 4. Next operation of matrix on matrices is negative of a matrix. So whenever you introduce to a new term, let's first learn how to generalize it, right? So here it says that negative of a matrix. Now take a real number, as for example 10, which is the integer. So if we take negative of 10, then what you will say? You will say minus 10, right? Minus 10 is the negative of the number plus 10. Now if I am asking you that what is the negative of the number minus 50, then minus 50, you will say that negative of minus 50 is minus of minus 50, right? Then it will become what? It will become plus 50. So similarly in case of matrix, we will do the similar. We have taken a matrix which is capital A. These are the elements of the matrix which contains both the positive and the negative number, right? Now, what is the negative of a matrix? In the previous operation of matrix, we have seen that how to scalar multiply a matrix, right? In that example, we have taken a generalized term, that is k, constant k. Now, by same method, we will take minus 1 in the place of k. Why? Because it is a negative of a matrix. Whenever we will ask to find any negative of a matrix, we will just multiply the whole matrix by minus 1. That's it, right? So let's do the same. Let's multiply minus 1 by the whole matrix. Here the matrix is this. Now let's multiply minus 1 with the matrix. So minus 1 into minus 1 is plus 1. Minus 1 times 0 is 0. Minus 1 times 3 is minus 3, and so on, right? So whenever we will ask to multiply any matrix, or we will ask to find a negative of any matrix, what we will do? We will just multiply minus 1 with the whole matrix, right? So next we have multiplication of matrices. When we can multiply two matrices? So if we are given two matrices, as for example here A and B, and if the number of column of A is equal to the number of row of B, let's see this clearly. The number of column of A should be equal to the number of row of B. We know the order of the matrices, and the order is generally written as the number of row by the number of column. So here in this matrix capital A, this one is the number of row and the second one is the number of column, right? And we have to follow the property of what? That the number of column of the first matrix should be equal to the number of row of the second matrix. The second matrix is capital A and the number of row of the second matrix is small n. This is a small n, this is also small n. We don't need to see or worry about the number of row of the first matrix and number of column of the second matrix. We only check the column of first, the row of second, the number of column of first, the number of row of second matrix. If these two are equal, then only we can multiply any two matrix. Okay. So now let's take two matrix A and B. This is A, this is B. What is the order of this matrix? 1, 2, 2, 1, 2, 3. So 2 by 3. Order of the second matrix? Order of first matrix is 2 by 3. Order of second matrix is 1, 2, 3, 1, 2. That is 3 by 2. Now let's check the property holds or not. The number of column of the first matrix, number of row of the first matrix, is they equal? Yes, they are equal. Both are 3. So we can clearly multiply these two, right? Let's multiply. How do we multiply that? This and this. Okay. Like this and this. See this carefully. We will multiply the first element of this row with the first element of this column. Second element of the row, second element of the column. Third element of the first matrix, third element of the second matrix. Let's do that. 1 into 3, 3 plus 0 into minus 1, 0 plus 2 into 0, that is 0. This is the first element of the new matrix. The next element is this one into this one. Okay, let's do that. 1 into 0 is 0, 0 into 2 is 0, 2 into 1 is 2. Okay, the third one, multiply this row with the first column again. 0 into 3 is 0, 1 into minus 1, minus 1. Minus 1 into 0, 0. Again we will multiply this row with this column. 0 into 0, 0. 1 into 2, 2. Minus 1 into minus 1, minus 1. So the resultant matrix is 3, 2, minus 1, 1. Order of the matrix is 2 by 2. So for any kind of matrix multiplication, the order will be the row of the first matrix, column of the second matrix. These two will be just think like that the similar are cancelled out, which is side by side, and then 2 by 2 will be the order of the matrix. This is the resultant matrix of the matrix multiplication of A by B. So this is the closure of our lecture 3. In next lecture we will discuss another topic of matrix. Thank you.